Can you see the whiteboard? Okay. Uh, in our lessons, yeah, basic basic elementary functions. We have already discussed about this. So if we have f of x equals to x, then we call it identity function. If h of x equals to x square, then we call it square function. If x cubed, then you call it cubic function, and then square root function, cubic root function, cube root function, and then absolute value function. So here, if you are given mod x, that is called absolute value of x. Okay. So basically, what is the definition of absolute value? Uh, yeah, absolute value. What does it mean? Yeah. Simply, if we call it that, if you give it some values which can be positive or negative, then you will get the output as positive, right? It can be positive or even it can be negative. Yeah, yeah. If you put negative 2 here, then the result will be positive 2. Even if you put 2 here, the result will be 2. Yeah, yeah. That is absolute value. So that means if the input positive, then you will get positive. If the input is negative, then you will get the positive. That means the output doesn't depends on the input sign, right? So is it okay? Depends on the sign of the input. If it is positive, then you will get positive output. If it is negative, you will also get positive output. If I go for here is the definition of modulus. The absolute value and real number x can be defined as absolute value of a real number can be defined as. That means we will get modulus. We can write modulus x as negative x when the value of x is negative, less than 0. But we can write it as x when the value of x is greater or equal 0. That is the definition of absolute value of a real number x. So here, if you put the value, if you are given, or if you put x -5, then how can you calculate this? Which one will be considered from here? There are two functions here, right? There are two functions here. First one is this negative x, that is absolute value of x is equal to negative x. If the value of x is negative, okay, But more absolute value of x is x while x is 0 or greater than 0. That means if you are given here x equals to -5, then absolute value of x will be here -5, right? So the calculation is uh, we have to consider this function, right? That means it will be -5. So it will be +5. That is what I have said. If you put positive or negative value, the output will be positive. I, that means based on the value of x, the function will be decided which one you have to use. No, but I have just explained the mathematics behind this. But if you put any number which is positive or negative, we already know that the output will be positive. So even it is -10, we will have 10. But how you are getting 10, positive 10? Where is negative sign? Where is the negative sign? Yeah, yeah. So that is the mathematics here. So we have to put negative over negative x. So it will be positive 10. Okay. That is also called piecewise function. The function is segregated into two parts. Okay, this type of function is called piecewise function. That means there are some pitches over there in a function. If we go for another example, uh, here is the one. Okay, but if we go for this one, that is y equals to x squared -2. That means what are we getting here? That is uh, the graph of this function is this. Since the domain here, what is the domain of this function? That is -infinity to +infinity. Okay, but how can we define that the domain of this function will be positive infinity to negative infinity? If you look the arrow sign here, yeah, yeah. Okay, no. Basically, domain is totally depends on the values of x. That is, we already discussed about this. That is the input. We call all input domain, right? So here, if we look at the function y equals to x squared minus 2. So here is the term. Is there any value of x for which you will not get the output over real number? Okay, basically, is there any value of x here for which we will not get the output? Is there any value here? Here, okay. How can you define that? That is y equals to x square minus 2. That means here every value x will cover every value of real numbers. from the set of real numbers. That means if you put -1, then you will get the output. If you put +1, +2, you will get the output. If you put -100 even here, you will get the output, right? So if you put the +100, you will get the output also. That means it covers all the numbers, all the real numbers. So we can say that the domain of this function is -infinity to +infinity. Also, we can, okay, okay. Now, we can also identify the domain from the graph also. That means all values of x are called domain, right? All possible values of x are called domain. So here, this graph, if we extend the graph, it will be up to this and it will be up to this. That means, so if we now go to the number line, then it will be up to -infinity to +infinity, right? So the graph of this function is positive, -infinity to +infinity. But if we look at the third one we are given here, that is, okay. Now, second one, that is b here, okay. Y equals to 2 minus x square. In our last session, I have discussed about the quadratic. That means the shape of the quadratic is U shape, right? That is parabolic shape. It will be concave up or concave down, based on the coefficient sign of the coefficient of x square. We decide whether it will be concave up or whether it will be concave down. If the sign is positive, if the sign of x square is positive, then it will be concave up. Yeah, U shape, right? So if the sign of the x square is negative, then it will be opposite U, down U, right? Down U. Okay. Now, if we combine these two, okay. Now, if we see here, okay, okay. If we look at the function, or look at the graph here, that means this, in this function, if we take up to this, then the values are negative, right? The values of x are negative. Okay. Since if we extend the graph, it will be up to negative, right? -infinity. Okay. And here up to 0. Here the value of x is 0, right? 0. So we are considering the value x less than 0. If we consider this one, then we will get this curve, this one up to this. Okay. If we go for x greater than 0, then we will get from here this. So the center point is 0. Similarly, for this graph, if we consider x less than 0, that is negative. So the graph will be this, right? Okay. And if we consider x greater than 0, then the graph will be this, right? Okay. Now, if we combine this, if we combine this, that means if we consider x less than 0 from here, and if we consider x greater than 0 from here, then what will be the combination? Here it will be this, and here it will be this, right? The combination of these two graph is number C. Look at the function here. Y equals to x square minus 2. If x less than 0, then we have this graph. But if y, okay, okay, yeah, 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 minus infinity to positive infinity, since the graph extends up to infinity. And also you can remind that all uh, the function uh, consisting of polynomial, that is all polynomial function has the domain negative infinity to positive infinity. Okay. Since there is no denominator, or even there is no square root, if we have a rational function that has a denominator, so denominator can't be 0, right? Uh, and also, if we have a square root function, then the term inside the square root can't be negative. That's why we are considering that for a square root function, uh, the term inside the square root must be greater or equal 0 for domain. Okay, so these two have the case, except these two, then we will have the domain negative infinity to positive infinity for all quadratic functions, since the graph moves up to infinity, negative infinity, and here positive infinity. Okay, now I'm talking about this one, number C. So this C is the combination of, sorry, here x less than 0 to x greater than 0, that means up to this, and here this portion, that is the combination. Here look at, if x less than 0, then we have this one for this function, and if greater than x greater or equal 0, then we have here this one for this. So now number C, we call this function is a piecewise function. So what does it mean by the piecewise function? How can you explain it? What is piecewise function? Okay, all right. So simply, if we explain it, that will be piecewise function is basically combination of two or more functions, right? No, no. Here, yeah, no, no. Okay, I'm showing you a demonstration. Then it will be, I think, it will be clear to you. Uh, and you see the Desmos here. Can you see the Desmos? Can you see it? Okay. Here, if we write a function that is f of x is equals to x uh, square, then plus 2. So basically, if I show you the graph that is f of x equals to x square, then it looks like this, right? Okay. So this is the basic function, that is a square function or quadratic function. Now, if we move it, or if we add 2, f of x equals to x square, and if we add plus 2, then what happens? Blue one, what you see here, it goes up 2 units, right? Okay, I'm just crossing out so it will be easy for you to see. Okay, now, okay. Now, so what is the basic difference here? Since we have added plus 2 here with the x square, right? So it moves up to 2 unit up, right? Okay. And if I put negative sign here, negative, then what happens here? Blue one, down 2 units, right? So if I put plus 3, what does it mean? It will up 3 units, 3 units. Okay. Now here, if I add f of x equals to x plus 2 square, then what is the basic difference with the main function? I have added 2 with the x, then take square on whole term, right? So it moves left side 2 units. Now, yeah, yeah, whole 2. Right. X is equals to minus 2. Yeah, that's why minus the function moves to left, negative direction, 2 unit. But if we put plus here, then what happens? If we put negative sign here, negative sign, it moves up to right. So for y, if you have y, now you can see it, the blue one, x square plus 3. That means if we added something with x square, then it will move up to with it will move just along with y-axis, right? It will move up or down if we uh, put if we add something with x square, then the graph will move up and down. But if we add something with x, add or subtract, then the graph will move left and right. Okay. But the direction for y is if you have added something, then the graph will move up. If you subtract some values from x square, then the graph will move to down, right? But for x, it is opposite. If you subtract something from x, then the graph will move to right, right? Yeah. So if we use negative sign here, then it will move to right, and if we put positive sign here, then the graph will move to left. But for y, for constant terms here, these are called constant terms. So if we add something, then the graph will move up, and then here f of x equals to x square, then minus 3. That is the purple one. So if we now see the difference of these two functions, that is 3. So blue one just move up, and the purple one moves to down. Okay, but okay, is it okay if you put x plus 2 square? Oh, okay, now see the difference, green one and the black one. Okay, okay, that is called the shifting of graph. And also now uh, if we add some coefficients, then what happens here? Okay, this one is the basic function, right? That is the main function. Okay, now if we add f of x equals to 2x square. Okay, we change the color here. Okay. Now see the green one. What happens here? What is the basic yeah, what is the basic difference here? The function just green one squeezes. The main function is just spreads. Okay, but the green one is squeezes. So it means if we add some coefficients with uh, the main function, that is f of x equals to x square, with if we add 2, that means here the function 2 times squeezes. But if we add increase the value here, if we put 3 here, then it will be more. If we put 10 here, then what happens here? The value increases, the function squeezes more. Yeah, right. So now if you put negative sign here, what happens here? Just opposite, which I mentioned earlier in our last session. That means the based on the sign of the x square, right? So we will get whether the function is concave up or concave down. If we have the negative, then it will be just opposite u. If we have the positive sign with the x square, then it will be U shape. Okay. Now I was just talking about if we have here x is uh, greater than 0 for first one, greater 0, then what happens? For this one, red one, the graph starts from 0, right? The values of for this graph is only x, right? The values for the red one, values of x is considered only positive values of x. That's why there is no portion over the left side. And if we put here x less than 0, then what will we get? Can you tell me? Negative infinity, right? So if we put 0 here, so the graph will be just like this here. Okay. But if we put here 2, then the graph will start from 2. That means the domain of the first one, red one. So domain is the values of x, right? So the domain will be start from 2, right? 2 to infinity. Is it clear now? The domain of this function will start from 2, and it will be 2 from to positive infinity. And the domain for the blue one will be negative infinity to up to 0. 0, right? Okay. So we can say these two functions, if we combine these two, if we combine these two, then we can say that this two is a piecewise function. So it is not mandatory. I am showing you that it is not mandatory to start from 0 or include 0. Okay. So now if we move to our lesson, then here, so now look at the example here. The graphing piecewise defined function g of x equals to x plus 1 when the value of x is in between 0 and 2, where 0 included. Okay. And g of x equals to 0.5x if the value of x is greater than 2. So we have two functions here basically. G of x equals to x plus 1, and another one, g of x equals to 0.5x. Okay, so we have here two function, and for this function the domain is 0 to 2, where 0 included. This is the domain. That means the function started from 0 and it continues up to 2. So that is the here is the domain. for this function. And here the circle, if you just notice the circle here, uh, this one, this circle is filled up, but this one is empty. What does it mean? Empty. That means 2 is not included. Okay. 0 is included. That's why these circles filled up. And here another one, that is, we have two functions here, that is h of x. So h of x equals to negative 2x plus 4 when the value of x is in between 0 and 2, where 0 and 2 both are included. That means this one will be negative 2x plus 4. So it is a linear function. It is a linear function, right? Power of x is 1. If the power of x is 2, then we call it quadratic function, right? But a quadratic function, the graph of quadratic function is parabolic shape, that is U shape, right? But the graph of linear function is a straight line. The graph of a linear function is a straight line. Uh, till 2, right? Till 2, right? So second one, h of x equals to a 2 to up to infinity, right? Okay, so equals to x minus 1. This one also a linear function, so we will get a line from this. So if here is 0 and here is 1, here is 2, so the graph will be here negative. So it will be 0 to 4, just like this. Okay, and then x minus 1. So it will be just like this. It will continue up to infinity. 0 here, circle will not fill up, but here we have to fill up the circle, and this one will be the empty circle. Okay, the graph will be just like this. I'll discuss about it, why the line is just downward and this one is upward. I will discuss about it in our next session. That is totally based on the slope. That is called the gradient of a line. Gradient. In that topic, I will discuss about it. Then you can gradient or slope. Okay. So based on this, we can easily decide whether the graph is upward or downward. It totally depends on the gradient. If the gradient is positive, then it will be upward, and the angle will be just in between 0 and 90. Yeah. Okay. 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 Since this one is x-axis, right? X or x prime, and this one is y. Okay. Okay, I got your question. That is, the value of x is just in between 0 and 2, right? So the graph of this function will be available just in between zero this value. Okay, so if we consider this one as y, so the equation becomes y equals to negative 2x plus 4. This is the equation. Now if you put x, then you will get y. So for x, that is, if you put x1, okay, at first put 0 here. So y is 4, right? If you put x0, then you will get y. Okay. Okay. And then if you put 1, then what will be the value of y? 2. Okay, good. Then if you put 2, then what will get? What will be the value of y? Okay, that is 0. So uh, the first point will be 0, 4, right? So 0, 4, x is 0, y is 4. So this one is 4. This is the 0, 4 point. And then for 1, 1, 2. Okay, 1, 2. So if we consider this one as 2, so for 1, 2. Okay, this is the 1, 2 point. And then x0, y0, sorry, x2, y0. So okay, I'm wrong here. So that means the graph must be just here. Okay, that, yeah. So accurate form of the graph will be this. Is it clear now? Okay, now uh, for the next one, that means y equals to y equals to x minus 1, right? Now, if you put x equals to 0, okay, sorry, we have to just put the values of x that will be greater than 2. Yeah, so we can't put uh, if we start with 2, then we have 0. Okay, then 3, so it will be 2, right? Oh, if we put 2, then we have negative 1, not 0. No, 1, 1, 1, 1, 1. Sorry, 1. Now, if we put 3 here, then we will have 2. If we put 4, then we will have 3, right? So we will have a graph that is, here is 1. If you consider this one is 1 and this one is 3, so the graph will be start from here, that is the 2, 1, and then if this one is 3, 4. Okay, so 3, 2, 3, 2, that means this point, 3, 2. Okay, and then 4, 3. So 4, 3. So it will be this point, right? Now, if we add it, then we will have a graph just like this. It will be up to infinity. Okay. Okay. I think how I just draw the graph. How can we draw the graph after seeing the equation? Uh, it will be clear to you if I discuss about the gradient or slope. Okay, that is also very important in economics. Important topics for economics based on this law. Sorry. Okay. Basically, I'm saying that in economics, gradient or slope part to have the basic understanding of these topics is very important because based on these topics, you have to decide whether the graph should be upward or downward. That is basically related to demand function or price demand graph or even revenue graph we have already discussed in our last session. Okay. Today basically, yeah, okay. That is the reflection. That is stretches, how the function stretches or shrink. Yeah, yeah. And also reflections. That is, if we put f of x equals to x square, then we have this type of graph. But if we put f of x equals to negative x square, then we have the reflection of this graph, right? Downward. That is the reflection. And the x-axis, yeah, the x-axis works as like as a mirror here. Yeah, yeah, yeah. And here is this, which I have shown you, and this one is the description of that work. Here, how the graph shapes vertically and horizontally. That means if we add some number with the x, then it will move up to left or right. That means it will shift horizontally. Yeah. But if we add something, yeah, 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 yeah. So if we add something with the absolute value, then the graph will shift vertically. It will go up or down. If we add something, then the graph will move to up, and if we subtract something, then the graph will move to down. Okay, that is called the vertical and horizontal shifts. So I think is it okay? Okay.